Hello, guys. Welcome back. And today we will look at quite simple, a very simple neural network. So, what we will be looking at is visually shown here. We have two inputs, x1 and x2. Then we have three neurons. We'll explain what a neuron is. We will use an activation function, which I will also explain. And then we will multiply by the weights and find an output. So what we will try to accomplish is actually adding 2 plus 2 or 4 plus 4 to get 8 or 2 plus 2, 4. And without wasting any time, let's just do the explanation step by step. So we have the input layer. And in this input layer, we have two inputs. Could have been for visual other models, you have a lot of inputs, but just to show you the concepts, we have x1 and x2. Then we have the hidden layer. Sorry, you have the hidden layer. In the hidden layer, you have a neuron, another neuron, and the last neuron. So before doing anything, I will explain what a neuron is. So you have a neuron here. It has a weight which is connected to it, and this weight comes from the layer before the neuron. So in our context here, it will be the input layer. So let's just start connecting each of the neurons to the input, which we already know each that the neuron will have an input from the layer before. And the input is decided by the type of layer you choose. So here we have a fully connected layer. That means that each neuron is fully connected to the neurons in the layer before it. So that those are the weights that you see to the left in the screen. So let's say for the first neuron, we have 0.991 from x1, and from x2, we have 1.026. So this neuron will actually, this neuron will take the two inputs from x1 and x2, 0.991 and 0. Oh, it's actually 1.026. 1.026. And we will calculate the value based on these two weights. So what does the neuron do? It takes the value from the weight, which is, so the input here is, let's assume we are adding 2 plus 2. It will take the input from x2 and x1, 2 multiplied by that, multiplied by the weights. So 991 and 1.026. That is the first step. And this step can be explained by that we have the weight multiplied by the input. And then we have the bias, which is actually subtracted from the whole of this. So the bias in this context is minus 0. As you see here, minus 0.007. Oh, 0.007 minus. We actually add the bias, but since it's a negative value, we just minus 0.00706, and we get the value. This gives us 4.03. So let's go back and see 4.03. That is good. And we do it for the rest of the neurons, exactly the same calculation. And we will get 1 point minus 1.83 and 3.27. So after doing this, we've just done some linear calculation. As you can see, it's this actually is the linear function. So you have the slope and the intercept, if you think about it like that. But we need to add some nonlinearity, and this is where the activation function comes in. So if you're wondering what activation function is, just go to this ML cheat sheet, which shows you what a neuron is, which you already explained, and go to activation functions and read a little bit about this. And you will see that activation functions live inside a neural network layer. They modify the data before passing it to the next layer. That's important because that's what we are going to do now. And we it gives us the power to actually do the complex nonlinear relationships. So we have decided to choose rectified linear unit, which I have another Google Colab notebook that goes through all of these activation functions. And the relu function looks like this. What actually relu does, it takes the values before x, 0, x is equals to 0, and makes them all 0. And for the positive values, we do keep the values. So let's go back to our neural network and see. So the relu layer here is maximum of 0 and 4.03, which is equals to 4.03. And in this context, we do the same, we get 0, and here we get 3.27. Now you have done the math, which is multiplying the weights and adding the bias, and applied the activation function, which is quite important. And now we can go to the output layer. So from here we do of course have some weights, and we calculate with the weights. As you can see, you remember here we use the weights exactly as the same way as we did in the layer before, and an output of we get the output layer here, yeah, the output. So this is a quite simple neural network, and let's just jump over into our Python notebook here and our Google Colab notebook. I've already done the weights for you, and the biases are in place. Let's just run them again. And we define the activation function, which is very easy in this context. It's max 0 and x. So x is the output that we will be having here. So there. And the most important part now, we actually set up the neural network. So what are we doing here? This is a function that has two inputs, and we define the first neuron 1, and neuron 2, and neuron 3, of course, here. 2 and 3. And what we do now is actually we apply the relu function on top of the weights and the bias. We get the output that we calculated by hand in our notebook here. And after that, we predict the value. So the predicted value will be y hat, which is the weights here, multiplied by the output we had from the layer before. And this gives us, let's see, yeah, let's do this. And then something we haven't covered yet, this is the loss. So this is mean squared error, which is quite simple. You just take the value which is predicted and subtract the value which you know is already 4 plus 4 is 8. So we know that. We will be doing it here. So let's run this. You see that we get 7.98 approximately, which is quite close without doing a lot of fine tuning or anything, or not fine tuning, but we haven't back propagated or tried to find the right biases and weights, and we still get this close of a value, and this is the loss. So we have done a lot. You have actually implemented your first very easy neural network, and you've done an activation function, calculated the weights and the biases for each neuron, and you have predicted a value with two inputs. So that's quite easily explained, and I would recommend that you go in here and try to understand the different concepts in the neural network. What is a neural network, and how the neurons work? What is the synapse in between the layers, and what is the bias? So just go in here. Shout out to this cheat sheet, which has always been open for me. If I don't understand anything, I just go here, and from here I just go on to reading papers. So thank you for this time. And next time we will actually cover how the activation function works and when to choose the right activation function.